Hey guys, the objective for this video is to determine the angular twist in a composite column. So let's have a look at our question here. We've got a composite column which has 5mm thickness brass over a 40mm diameter steel core. And the total length of the shaft is 2 meters and it's fixed at one end. We've got a shear modulus for our steel of 77.2 gigapascals and a shear modulus for our brass of 39 gigapascals. The torque that's applied to our shaft is 600 Newton meters. And what we need to do is we need to determine the max shear stress in the brass bracket, the max shear stress in the steel core, and determine the angle of twist. So what I'm going to be doing is I'm going to be denoting the torque in the brass, TB, and then the torque in the steel, TS. So by equilibrium, the torque in the brass plus the torque in the steel has to be equal to the total torque that's applied to our shaft, which is 600 Newton meters. So this is going to be our first equation. We've got two unknowns here, the torque in the brass and the torque in the steel, and we're going to need that to determine what the shear stress is. So we're going to need to come up with another equation in terms of the torque in the brass and the torque in the steel. So from compatibility, so we know that we've got our composite section here, and the sections can't move against each other. So they're solid, there's no movement between the sections, so that means that the angular rotation is the same. So the angle of twist in the brass is going to be equal to the angle of twist in the steel.